Now today we discuss how to solve the first order first degree ordinary differential equation. So first we defined the one method whose name is a variable separable method. So if the differential equation of the first order and first degree can be simplified in the form f of x dx is equal to g of y dy, where f of x is a function of x only, g of y is a function of y only. The solution of equation 1 can be obtained directly by integrating it on both sides and adding an arbitrary constant to any one of the two sides. That means we integrate both sides, so integration fx dx in, is equal to integration g of y dy plus c. So equation 2 is the required solution where c is the arbitrary constant. So this is the simplest method. If any differential equation whose order is a first and the degree is 1, then if we simplify the first order first degree equation this form, that means the x variable separate, y variable separate, then we write this form, then easily we integrate both sides and we get the solution. As for example, suppose given that the solve dy by dx is x y. So obviously this equation, this is the first order first degree equation. So dy by dx is equal to xy. So y is here, dx is here. So dy upon y is equal to, we write x into dx. So this form is only y variable, or this form is only depends on y, and this term in the right hand side form is depends only on x. So we apply the separable variable method. So taking both side integration, so dy by y is integration x dx. So therefore we can say log y is equal to x square by 2 plus c. So this is the required solution. Now another example, suppose uh, another example is solve y into dy by dx is equal to sin x. So now we will try. So obviously, in the right hand side is sin x. So left hand side dx, we convert it here. So y dy is equal to sin x dx. So left hand side depends only on y, right hand side depends only on x. Taking both side integration, so we get integration y dy is equal to integration sin x dx. We get y square by 2 is equal to sin integration is minus cos x plus constant c. So this is the required solution. Now next topic, homogeneous equation. So homogeneous equation. So first we define homogeneous function. So what is the definition of homogeneous function? So a function f of xy is said to be a homogeneous with degree n if it can be expressed as f of tx comma ty is equal to t raised to n f of xy for all x comma y. So homogeneous function, that means any function f of xy can be expressed in this form. That means x is a replaced with tx, y is a replaced with ty, and then t is common, and the power of t is the degree of the homogeneous. Now, what is the definition of homogeneous equation? So, a differential equation of the form dy by dx is equal to f of xy upon g of xy is called homogeneous differential equation if f of xy and g of xy are homogeneous function of same degree. So again, the equation form is a dy by dx is equal to f of x comma y upon g of x comma y, where f of x comma y, g of x comma y are homogeneous function of same degree. Now thus we can write dy by dx capital F y by x upon capital G y by x, where small is equal to h of y by x. So indirectly dy by dx is equal to h of y by x, where f of xy, that means small f of xy is x raised to n f of y by x, and small g of xy is x raised to n g of y by x. So indirectly we input f of xy and g of xy here, then we get this form x raised to n, x raised to n, same degree, x raised to n is cancelled, then we get this form, and this form we consider h of y by x. So now this is equation 1. Such an equation can be solved by substitution of y is equal to ux, and thereafter integrating the transfer equation dy by dx. So we differentiate with respect to x. So dy by dx is equal to x derivative 1. So u plus x into du by dx is equal to f of u, because y by x we consider u. So indirectly, if the equation is a homogeneous, then first we can take the substitution y by x is equal to u, and y by x is equal to u, so we write y is equal to ux, and therefore dy by dx is replaced with u plus x into du by dx, and therefore log x is equal to the integration du upon f of u minus u. That means here we write u plus x into du by dx is f of u. So f of u minus u. So du upon f of u minus u is equal to dx upon x. And taking integration, then we get the solution form. So now we discuss the example. Solve dy by dx is a y by x plus 10 y by x. So here given equation is a homogeneous. Therefore we consider y by x is equal to u, and implies y is equal to ux. Y is equal to ux, so dy by dx is equal to u plus x into du by dx. So therefore dy by dx is replaced with u plus x into du by dx. In this equation 1, we get u into x du by dx is equal to y by x is a u plus 10 y by x is a 10 u. So u plus x into du by dx is equal to u plus 10 u. So implies x into du by dx is equal to tan u. U cancel. So we write tan u, we apply the separable variable method. So tan u here and dx, x term right side, u term left side. So 1 upon tan u, that means cot u du is equal to dx by x. And obviously we apply both side integration. So we get log sin u, because cot u integration is a log sin u. 1 upon x integration is a log x, and we consider plus log c. So therefore sin u is equal to x into c. Now u is replaced with y by x. So the required solution of the given equation is sin y by x is equal to x into c. Next example, y minus x, solve y minus x dy by dx is equal to x plus y into dy by dx. The solution, first we write the given equation in the form dy by dx is equal to y minus x upon y plus x, because here we write x is here and this term is in right form. So y minus x is equal to y plus x dy by dx. So we write dy by dx is a y minus x upon y plus x. Now take x common, so y by x minus 1 upon y by x plus 1. So now this is the homogeneous equation, first order, first degree. So y by x is equal to u. So we write y is equal to ux. And obviously we take both side derivative with respect to x. So dy by dx is equal to u plus x into du by dx. So now we replace dy by dx this form in equation 1. Then we can say u plus x into du by dx is equal to y by x is a u. So u minus 1 upon u plus 1. So implies x into du by dx is equal to u minus 1 upon u plus 1 minus u. So implies x into du by dx is equal to minus u minus 1 minus u square minus u. So we write minus u square plus 1 upon u plus 1. So implies u plus 1 upon u square plus 1 du is equal to minus dx by x. And then we can say u upon u square plus 1 plus 1 upon u square plus 1 du is equal to minus dx by x. So therefore, integrating both sides, because equation 2 is indirectly a indirectly separable variable equation. So we apply the integration both sides. So we get 1 by 2 log u squared plus 1 plus tan inverse u is equal to minus log x plus log c. Now substitute y by x with u. So the answer is 1 by 2 log y by x whole square plus 1 plus tan inverse y by x is equal to minus log x plus log c.